Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 9.6 entitled Solving Quadratic Equations by Using the Quadratic Formula. Now this is the last method that we're going to see for how to solve a quadratic. So we can graph them, or we can solve them algebraically, or we can use this formula. There's another way that we can solve them, but we'll save that for the next chapter. Okay? So here's the quadratic formula. This is really important. In class, I will sing a little song or a couple little songs to help you remember it. But basically, it is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And the a's and the b's and the c's come from the standard form for a quadratic equation, where you have the ax squared plus bx plus c. So those a and b and c values that we've been working with for graphing are going to come into play now for the quadratic formula. And when we graph, we've just been using the negative b over 2a. That comes from right here. Okay, so that's connected to the quadratic formula as well. And now we're going to use the c value too. We'll have 4 times a times c. So we finally get to use the c. Now when we're solving equations with the quadratic formula, we want to make sure that the equation's all set equal to 0 and that it's in descending order. That's what the standard form means here, that everything's in descending order. Oops. Descending order. And then we want to identify our values for a, b, and c, just like we've been doing. We're going to substitute them all into the quadratic formula, and then we're going to simplify. And we simplify by using our order of operations. So we're going to start by simplifying the discriminant. The discriminant is the stuff that's inside the square root. Okay? It gets a special name. We'll see more of that in the future. But we're going to start there because the radical is like a big set of parentheses. It's a big grouping symbol. And we will get 2 answers because of that plus minus that we have. Okay? So, for example 1, let's just practice making sure that we are really good at writing the quadratic equation in standard form. And again, that just means that it's all set equal to 0. Okay, that's what the standard form means. So for part A here, we have 2x squared equals negative x plus 6. So I have to get everything set equal to 0. So I'm going to add the negative x over, and then I'm going to subtract the 6 over. So that'll get me 2x squared plus x minus 6 equals 0. So now it's in my standard form where it's all on one side, it's all in descending order, every term is accounted for. You could put a 1 in front of the x if you would like. Okay. And then it says to identify the values for a, b, and c. We've been doing that all chapter, so you know that a is 2, b is 1, and c would be negative 6. Okay, for part B, here I have 2 equals x squared minus x. So this time, I'm just going to move everything to the right side, because that's where the x squared is. Usually we move everything over to the side where the squared term is. So I'm going to subtract the 2 over. So I'll have 0 equals x squared minus x minus 2. And if you don't like the 0 being on the left-hand side, you can flip-flop it. You can just write it x squared minus x minus 2 equals 0. You can write it like that. Either way, completely acceptable. And then you know that there's a 1 in front of the x squared and a 1 in front of that x. So your a term would be 1. Your b term is going to be negative 1 though, and your c term is going to be negative 2. Okay, so that's the first couple of steps that we'll do for all of these problems. And then basically in example 2, what we're going to do is we're going to do the quadratic formula after we do that. After everything's written in descending order and we know our A, B, and C, we'll do the quadratic formula. So for part A, I have 2x squared minus 3x plus 1 equals 0. So it's all set equal to 0. Everything's in descending order. I have all of my terms. I don't need a placeholder. So I need to know that A is 2, B is negative 3, and C is 1. And now I'm going to substitute into the quadratic formula. I'm sorry, the quadratic equation here. Okay, so this is what I'm going to be substituting it into. So we'll have x equals opposite b, so that's going to be a positive 3, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, obviously, it's going to be helpful to write the equation first and then substitute everything in one step at a time. So I'm just not writing down the equation first and then substituting. Okay. So now when we simplify, I'm going to start inside that parenthesis, the radical, which is like a parenthesis. So 3 squared is 9. And then there's a couple different ways you could think of this. You can think of this as 4 times 2 times 1, or negative 4 times 2 times 1. Okay, but 4 times 2 is 8, times 1 is 8, so then I have a minus 8 in here, all over 4. But now I'm not done simplifying inside my radical. 9 minus 8 is going to be 1. So I have the square root of 1 over 4. And the square root of 1 is really 1. So I have 3 plus or minus 1 over 4. Now, here's where I'm going to get my two answers. So I'm going to branch this off in two different directions here. I'm going to do 3 plus 1 over 4 to get an answer. And then I'm going to do 3 minus 1 over 4 to get an answer. So if you need to write those out separately, do that. Okay, that's where your two answers come from. So 3 plus 1 is 4, divided by 4 is 1. So there's one of my answers. 3 minus 1 is 2, and 2 over 4 is 1/2. So you can get fractions for answers now. A lot better to get fractions here with the formula than on a graph. Fractions are just more difficult to deal with on a graph. But if you do get a fraction for an answer, that's okay. If you get two whole numbers, that's totally fine. Now remember, what this really means is that this is where the parabola would cross the x-axis if we graphed it. So this parabola would open up because it's positive, and it would cross the x-axis at 1 and 1/2. So either that would be a really skinny parabola, or that would be a point low on the curve of the parabola, because 1 and 1/2, they're really close to each other. Okay, so let's try this again for part B and part C. Whoops. For part B, I have 8m squared plus 6m minus 1 equals 0. So it doesn't matter if you have x's or if you have m's for your variable, or if you have p's, or if you have c's, or b's, or a's, or l's, whatever. Doesn't matter as long as you have your squared term, your linear term, and then your number. And every term is represented. It's in descending order. So my A is 8, my B is 6, my C is -1. So we're going to substitute it into the quadratic formula again. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, now remember, if you have a negative number that you're squaring, you want to keep it in parentheses. So in part A, when my b value was negative, I put it in parentheses so that when I squared it, I remember that the negative went with. Here for part B, this B term is positive, so I could just write 6 squared without the parentheses. That's okay. So I'll have negative 6 plus or minus the square root of 36. And then let's see, we have 4 times 8, which is 32, times a negative 1 is a negative 32. So I have minus a negative 32, which is plus 32, all over 16. Now, sometimes when you're dealing with the quadratic formula, you get really big numbers. That's okay. Better to deal with the big numbers here than on a graph, okay? So I'll have negative 6 plus or minus the square root of 68 when I add those together, all over 16. Now, 68 isn't a perfect square, but I can break it down. So I'm going to rewrite this then, and I'm going to take out the biggest perfect square that'll go into 68. So that number is going to be 4. So that'll be the square root of 4 and the square root of 17. Okay? So how you can write this then is we'll have negative 6 plus or minus the square root of 4 times the square root of 17 all over 16. And then that'll be negative 6 plus or minus the square root of 4 is 2. Square root of 17, can't do it, all over 6, or 16. Now the only other thing that I can do is I can simplify all the whole numbers that aren't underneath the radical. So the 6 and the 2 and the 16, if I look at them, I notice that all of them are even, which means that I can divide all of them by 2. So this will really simplify down into negative 3 plus or minus 1 square root 17 all over 8. And if you don't want to put the 1 in front of the square root of 17, that's okay. You could just write plus or minus square root 17. That would be okay. Okay, so sometimes you don't get nice whole numbers. Sometimes you get a simplified radical in some sort of a fraction. So this is pretty complex. And if we were to actually get our two answers for this, they would be decimals. And remember, when we write a decimal, we either round it and make it too small or too big. So we want to leave our answer written this way with the radical because it's more precise than if we broke it down like we did in part A. We were able to break them down and get our two separate answers. Here we don't want to do that because that radical, the way it's written this way, is more precise than breaking it apart and getting our two decimal answers. Okay, so last one, part C, is kind of tucked up here. I have 5 equals x squared plus 6x. So this one I have to do a little work for. I have to subtract the 5 over to the other side so that I have all my terms on one side of the equation and they're all in descending order. Now again, if you don't like the 0 written in the front, you can rewrite it so that it's x squared, or you can even do 1x squared, plus 6x minus 5 equals 0. If you want to write it that way, you can. Either way is totally acceptable. Okay. And then my a term is 1, my b term is 6, my c term is the negative 5. So now I'm going to substitute. X equals opposite b, so negative 6, plus or minus the square root of b squared minus 4 times a times c. So make sure you get the negative with the 5 there, all over 2 times a. And then we simplify. So negative 6 plus or minus, then I'll have 36. Say 4 times 1 is 4, times negative 5 is negative 20. So minus a negative 20 is plus 20, all over 2. Now again, I'm not going to get a perfect square here. Negative 6 plus or minus the square root of, this will be 56, all over 2. So 56 isn't a perfect square, but I can break it apart. The biggest perfect square that goes into 56 is going to be 4. Okay, so I can rewrite that. -6 plus or minus the square root of 4 times the square root of 14 all over 2. And then that will be -6 plus or minus 2 square root 14 all over 2. Okay, so again, I have a radical that I can't simplify, so I'm just going to leave my answer this way. This is more simplified than making a decimal, but I can divide all the whole numbers, the 6 and the 2 and the 2. I can't divide the 14 because he's inside the radical, but I can divide all the other numbers by 2. So then I'll get -3 plus or minus 1 square root 14. And I could put it all over 1 if I wanted to, or I could just leave it so that was just the numerator. Okay, so you've seen 3 different problems now. One is pretty straightforward. The first one for A was very straightforward, but it does show you where you break apart the plus and the minus so that you get your 2 numbers. Sometimes they'll be whole numbers, sometimes they'll be fractions, sometimes they'll be one of each. And then you have 2 examples, part B and part C, where you get radicals in your answer. Okay? So don't be intimidated by that. If you do get a radical that's not a perfect square and it doesn't simplify, or if it just breaks down a little bit so that you can simplify it, just leave your answer written with the plus minus in it. You don't have to separate it and make 2 answers. You only have to do that when you have a perfect square and you know you're going to get whole numbers for an answer. Okay, so here's your homework so you can practice these concepts. Definitely, definitely, definitely show your work for this. Write out the quadratic formula at the top of your paper so you have it, and then do all the substitution. It's meant to be straightforward with the substitution and the simplifying. You're at a high level now of your algebraic skills where you can handle this, and you know how to break down the radicals. We've been working on that earlier in the chapter. So take it one step at a time, show your work, and if you have any questions, come on in and see us before school.